management. And now today I first of all welcome you to my channel, and today we are going to talk about mediation, multiple or serial mediation. In the previous video I had talked about single mediating variable. Model was single mediation. Now we will see how to calculate or how to find the double mediation model, or it is also called as sequential mediation or serial mediation. So the data which I am going to use is a dummy data, but for practice I can put it in the link. You can download the data and you can practice in RStudio. This is RStudio, and it is a free software which anybody can download. Now let us start with the usual process. I will call some libraries. You can see my first video on structure equation modeling, in which I have explained a little bit about everything. Again and again I will not say, but now let us start the process. So library, we will call the Lavan package. This is what we are going to use today. And then let me call the other library, which is semplot. Next one is mediation. And then we are going to take up, we will call flex plots. I have told you in that first video about structure equation modeling in R, about flex plot, how to download it. You can see that video, please. You have to download it once and then you can call always. And then for manipulating the database, we'll call library dplyr. That's it. And then library read R. Yes, I hope I have not left anything. Now important thing is we have to set our working directory. We can go to session and then we can say set working directory to choose directory. So wherever you have kept your data file, you have to choose that directory. So I have put it in the desktop, so I will select desktop and I will say open. So it has come here, but for the sake of script, let me put it here. Always it will set the working directory to desktop, or whatever you want you can do it. For me it is desktop, so I have put this. Now let us import the database. So what we can do is we can go to file and import database. It is a CSV file, so text. Let us browse. So desktop mediation, name of the file is serial mediation. This database I will give you. You can download, you can practice. So this is the command which is generated automatically. We don't have to write. Library readr is already mentioned above, so I will not copy that. And let us import it. And let me put that command here. And let me change the serial mediation as quite a big name for the object. So data d, let us put data 5. That is also quite big. Let us say df1. So df1 is our object which will save our CSV file, which is serial mediation, which is our database. And now view, obviously this is changed, so df1. Now let us do this once. Run this. You can run it from here after selecting it. See, we have this file now. What are the variables? X, Y, M1 and M2. X is the independent variable, Y is the dependent variable, and M1 is the first mediator and the second mediator is M2. So this is what we have with us now. So df1 is created. Let us remove this for removing the confusion. And once again I run it. Now we have df1 only. Okay, now we have done the basic things. Now let us start our actual programming. I can say here from session, I can say new session. It will create a divide. I hope so. Yeah, it's taking time. New session. It's not coming. Anyways, we can try it last time. Okay, maybe because I have magnified this too much for the sake of recording. It's not coming, otherwise it should come. So let me use the alternate way of doing the commenting. We'll write actual. This is not a program, it is a comment. What session would I have done? The same thing it would do. Okay, it is starting a new session, not the, leave that. I don't want. Yeah, close it. Actual programming. Starts now. So I think I did a wrong thing in that. Instead of selecting session, let us go to tool. Okay, now session Now in code, insert section, not session. I got confused. I'm sorry for that. Insert section. And I can write the same thing here. Actual programming starts now and say OK. Now see here, it has come actual programming starts now, and it has created a section for us, this one, dot dot dot. So let me remove this. I don't have to put it manually. What will happen is I can always, this section is like a cut. I can change sections, like from here I can go to the next section. Let us see, where is that? See, previous code region. So like for example, I can go to the next code region. Okay, 1 second. And what I'm trying to show you is the benefit of the section. So this is the first section. Like I can select this and I can go to that particular section. See, it has come to this section. Or if I'm here also, for example, I want to go to the next section. See, line or selection. I can go to the next one. I can go to the next, but it is not going to the section. Suppose the section is not started here. Suppose if I write something here, object 1. Now I'm in the second section, but if I want to go to the first one, I can click here. I can select this and it has gone to the section. Now many sections are there, I can click here. Suppose I make one more section. Let us see for experimentation. Okay, I go to code and again I insert a section. Say new section. New section, something I made. Now see, two sections are, new section is there, actual programming starts now. Now suppose I want to go to actual programming starts now. Let me click it. It has come to that point. So I don't have to go to the whole thing. I don't have to run all these things again and again. I don't need. I will go to the actual programming starts now and I will run that part. So that is the advantage of section. So this one more section is here. Let us see. Okay. I want to delete this new section. Suppose I will right click and I am not able to delete it. So let me see how should I do it. So new section. Okay, I can go to this part and let me come here and let me delete this, and then what will happen? I have only one. That section is removed. So now let us go back to the actual programming. Some learning for you and me. So let us start the actual programming. Object 1, I will identify this into, let us put this, and this I have just taken this from the Google, and let me start this. Select a brush. Okay, Let me use the medium one. Like for example, uh, so this one, and then let me select the size of this. Yes, and I'm not liking this. Okay. Let's select this one. Okay, now we have two mediators, M1 and M2. X is independent variable and Y is dependent variable. So what is the direct effect X on Y is through this path, F. Now X has direct effect on M1 through path A. M1 has direct effect on M2 through path B, and M2 has direct effect on Y through path C. So what is the indirect effect of this on Y? A into B into C coefficients. So this is the first indirect effect. What is the second indirect effect we are interested in? M1 X M1 Y. That means A multiplied by E. This is the indirect effect. What is the other indirect effect? X M2 Y. That means D into C. D multiplied by C is another indirect effect. So total effect what will be what? All these indirect effects multiplied by or added by the direct effect. So indirect effect plus direct effect will give us the total effect. So let me remove this once so that again it is there. Now we will use this particular diagram. You can make it in the on the paper also, or you can make it in on the computer. Whatever you want, you can. But it has to be made logically. It has to be thought of from your side only. So this is a simple one. So let us write the program. Okay. Now the first one we have to define is M1. M1 is predicted by X. So how can we write this? See, you have to see the arrow. On M1 it is coming from X. Yes. Any other arrow is coming towards M1? Nothing is coming. Only one arrow is coming. So X is M1 is predicted by X. We can say that. So let us write this. Our file is here. M1, M2, X and Y all are small. So let us make this model. M1 it is predicted by X. So M1 is predicted by X. Correct. Now second is what? M2. M2 is predicted by M1. There are two arrows and X. So let us write that. M2 is predicted by M2 is predicted by M1 and X. Actually, my neighbor is singing songs, so if you are able to hear, it's good. You can also enjoy. So M2 is predicted by M1 and X. Yes, M2 is predicted by M1 plus X. So what about other things? So we have finished M1, we have finished M2, whatever arrows are coming to endogenous variable they are called. And y is predicted by M2, M1 and X. So y is predicted by M1 plus M2 plus X. Am I right? Y is predicted by M2, M1 and X. Correct. Now also we have to define the paths. Let us do this little systematically. Yeah, now it's looking okay. And we have not put the inverted commas, which is very critical for us. When it is starting, it has to be closed. See, the color has changed. Okay. Now let us define the path between an M1 and X. What is the path? A. It can be anything, but we are going as per diagram. Between an M1 and X, it is A. So A is the path. A asterisk. We have defined this path now. Now let between M2 and M1, what is the path? M2 and M1. B. Yes or no? Between M2 and no. Yeah, M2 and M1 is B. So B asterisk. Simple. Between M2 and M1 is B. Correct. Then what we have to see? X and M2. X and M2. X and M2. What is the path? E. Let us put X and M2 is D. D. And then we have to put our asterisk. Then what should come before M1? Y and M1. What is Y and M1? Y and M1. It is E. Oh, sorry. E. Y and M1. E. So what we will do? We will write E and we have to just put asterisk. Simple. Then what we have to put before M2? Y and M2. Yes or no? Y and M2. Y and M2 is C. Again, this one. So we will put C asterisk and Y and X. X is left. What should come here? It is like a fill in the blanks. Sorry. Y and X. Y and X is F. So we'll put F here and put asterisk. So now we have defined our model with paths. It is very simple. In front of every variable, we have a path in between all the variables. So paths are defined. Now we have to find what? Let us see, indirect effects. What is the first indirect effect we have to find? A multiplied by B multiplied by C. So that is the effect which is M1 and M2 is having mediating effect of both the mediators. So this indirect effect, if it is significant, we can say that M1 and M2 are having mediating effect between X and Y. So X is impacting Y through mediator 1 and mediator 2. But generally when we are talking about mediation, we are more interested in individual indirect effect. But many softwares are giving us total indirect effect. But that may not be a correct picture because M1 may be impacting, M2 may not be, or M2 may be impacting, M1 may not be. But in totality, it will be significant. But that is a wrong picture. I want to know M1 has an impact or not, M2 has an impact or not. In totality, if M1 and M2 are having impact together, I mean M1 is having impact individually, M2 is having individually impact, and then together also it is having impact, then it makes sense. But if M1 is having impact, M2 is not having, or vice versa, and together it is having impact, then that is a wrong picture. So we have to see individual indirect effects of M1 and M2. So let us do that, and also together. So first, there are three effects here, indirect effects. One is A, B, C, this path. Second is so what was first? This. What is second? Say this. What is third? Say this. So three indirect effects are there. When we add these three indirect effects with direct effect, this one, we will get total effect. So I hope you understood everything. Now let us do one by one. We have to calculate here. Let me write an object for this. Indirect effect, say 1. Again we are going to put it same thing. Equal to, what is indirect effect 1? A into B into C. So let us do A multiply by B multiply by C. This is the first multiplication of all the paths. Second indirect effect, IND2. Okay. Second is this one. So what is that? A for M1 multiply by E. A multiply by E. So let us do that. A multiply by E. This is the second indirect effect. Or instead of writing indirect effect 2, let me write indirect effect of A into E is what? A into E is the indirect effect of M1. So let me write M1, indirect effect of M1. This is indirect effect of M1 and M2. Then third is indirect effect of M2. Let me streamline this. Okay. For M2, what is the indirect effect? For M2, it is D multiplied by C. D multiplied by C. That is for M2. So D into C. So let us do D multiplied by C. So this is for M2, this is for M1, and this is for M1 and M2. So there are three indirect effects. Now let us calculate the total indirect effect. Total indirect effect. So what is that? Again and again, I don't want to type. I will just paste it. Okay. What is total indirect effect? M1 effect, M2 effect, and M1 M2 effect. Three indirect effects were there. So I can write. Let us copy this. This one plus this effect, M1 effect, indirect effect, and M2 indirect effect. I've added to get total indirect effect. Simple. Now, what is total effect? Can anyone tell me? Okay, this is not the class. Total not indirect effect, total effect. Total effect. Again, let me make it a little short. Total effect. Total. Anything you can write, but for the sake of clarity, I'm naming it like this. So what is the total effect? Total effect will be what? Total indirect effect, which is this. We have already added 3. So let me write this again. Total indirect effect plus what? See this. Total indirect effect. This one. This one. This one. Yeah, I think. What is total indirect effect? This is 1, M1, M2 through M1, M2. What is second indirect effect? Through M1. What is third indirect effect? Through M2. 3 indirect effects are there. If I add all these 3 indirect effects, what is left? The direct effect is left. This is the direct effect. What is that? F. So I will add F to that total indirect effect. What is that? F. If I add F coefficient of path F, if I add to the total coefficients of indirect effects, I will get total effect. So now everything is there now. I will come to know everything about this model. I know everything now. It is flexible. This R is very flexible. In some other softwares, it will be a struggle for you. But this one, I'm not, I don't want to criticize. I know I want to stay away from that. But still, I'm telling you, this is more flexible. And you can do many things with it. So, all this is there. This indirect effect, and third indirect effect, and this is the direct effect. And after adding indirect effect with direct effect F, we get total effect. So let us see this. Total effect is already defined. So now our model is identified and it is put in object 1. So let us now let us write the fit the model. Fit 1 equals to sem. What is the object? Okay, object 1 comma data is equal to df1. Then we have to write SE, the sampling error method is equal to boot, which is a non-parametric method, non-parametric boot. Then bootstrap is equal to say 5000, but I'm putting 100. 5000 is good number, but let us put 100 for saving time. And this SC is equal to boot. What it will do is it will take out the samples and try to find the error between them. So why we are doing this is because Sobel's test finds indirect effects, but the indirect effects should be normally distributed. But they may not be normally distributed. We don't know. So for checking this, for having an alternative method to check it, we are doing bootstrapping. So this is about it. Then we will summarize. Summary of what? Summary of again fit 1. And then we write fit dot measures equals true, and we write r square equals true, and also we write parameters estimate capital E for fit 1. When we write parameter estimates for fit 1, it will show the confidence intervals. We need confidence intervals through bootstrapping. Now everything is done. Okay. Let me first clear everything now. Let us run it once again. Okay. So let me go to this point. I don't want to run everything again. Okay, now I have to run everything again. So let us run it once. df1 has come, object1 has come. This is our model. This is our data frame or the file of data, 140 observations. Now this is our programming which we have done. It is very logical, it's not difficult at all, really. So the best part is flexibility is there in this. Whatever I want, I can run the program. I can do the analysis properly. Okay, there is one error also. In variable definition, C. C is capital or small? Oh, sorry. It is small c. It should be small c. It should be small c, sir. Okay, let us run it again. I was doing bootstrapping. Let me increase the size. So everything has come, summary and everything. So let us see the summary once, what it says. So what is the method? It is maximum likelihood. Okay. See, 140 variables are there. Here also 140 observations. So it is okay. It should not be missing. Then there is some problem. Now test statistics 0 it is showing. That means it is a saturated model because this is a cooked up data which we have for only experimentation. So it's okay. Okay, then p-value is significant. Okay. Now CFI and TLI should be above. 1 is good. Over 0.9 is okay. Then less than 0.08, it is less, no problem. This is also 0.0, less than 0.08, no problem. This is not our tutorial for fitting a model. I have made a tutorial in structure equation modeling in R. That one you can see, in which I check the indices and try to fit the model in that particular video. So here regressions are significant, see, but this one is not significant. Some are significant, some are not significant. Ideally it should be significant. So what is the issue? I will see. R square is showing. Okay, now we have to see this indirect effects. Now see, M1 and M2 indirect effect not significant. M1 0.05 not significant. M2 significant, less than 0.05. Total indirect effect is significant. See now. What is total indirect effect? All this is added. And this M1, M2 is insignificant. M1 is significant, insignificant. Still, total indirect effect is significant. If I see if the software is showing only total indirect effect, I will say it is M1 and M2 has impact. But this is not correct. It's not a correct picture. So what is the correct picture? M1 has no impact. See this. M1 has no impact. M2 has impact. Now see the confidence intervals for M1. M1 is non-significant. We should have 0 then. M1. Let us go to M1. Where is the confidence intervals? Oops. Yes, sir. CI confidence interval lower upper. So let me go and check. Okay. Why it is not showing properly? Let me run this again. I want to see the confidence interval, but it seems the view is not correct, or I have expanded. Actually, I have, for making the video, I have increased the size of the fonts. Maybe something is cut. There's some issue. Let me go to view. Get actual size. Now let me again run it. Yep. That's why I put it 100, so that time is taken as less. Yep, something is there. Now see, because some data was removed, I mean unstructured because of the size. Now can I increase the size again to show you? Zoom in. Yeah. Again. Zoom in. Oops. Now let me increase this. Yes. Now you can see it properly. Now I have to see this. What I'm trying to explain you is what I was saying. Again I'm repeating. Indirect effect M2, M1 is not significant. That means what I said was confidence interval should have 0 in it. That means it is insignificant. So let us see if it is 0 is there in indirect effect M1. This is the indirect effect M1. So confidence interval lower is minus and upper is 0.064. So 0 is there in between. So that means it is correct. It is proven again that M1 has no impact. What is M1? This path is not effect having significant effect. It has no meaning. But M2 has meaning. This is having effect. Why we say M2 is having effect? Indirect effect or mediating variable is M2 is correct because M2 is 0.01 less than 0.05. And now second check is through confidence interval. That means in confidence interval 0 will not be there in this because it is significant. So indirect M2. Indirect M2 is this one. Both are positive. Lower is 0.060 and upper is 0.280. There is no 0 in this. So we can say easily that M2 is having an impact and M1 is having no impact in this model. See, total indirect effect, if I see, is significant. That means these three if I am adding. But that is not the correct picture. So I hope you have understood this. Now let us make some graphs and explain the same idea in graphs. Let us go back. Now these two libraries, FlexPlot and Mediation, when we are calling them, we can make a graph which is mediate plot. Now in mediate plot, you have to write in the same way. In mediate plot, x will come here, independent variable. No, sorry. Y opposite. Y will come on the left side and x will come on the right side. Everything will come on the right side. So dependent variable will come on the left side. So what it is? Y is predicted by, always we write like this. I am always saying, if you know, I am always saying y is predicted by, or y is function of, because it makes it easy for writing the understanding the concept. It is opposite actually. We're going in the opposite direction. See, if you see the diagram, it is like we are writing like this, not opposite. We are writing opposite. Y is predicted by x through M1 and M2. So we'll write y is predicted by x through what? In between we have to write through M1 and M2. Yes, correct. Now let us see the impact of, so writing all, we can make all also, we can write the last variable will come in the x-axis, remaining everything will come on the y-axis. So let us run this, let us see. Okay, control enter. Oh, sorry. Here the R cannot find where is this x, m, m1, m2, where to find, where to write data is equal to df1. Control enter. Now we should increase the size of this window. See this. If you write y, m1 and m2, it is showing slopes are different. So it is showing as if there is a mediating effect for both the m1 and m2, but that is not correct. Now let us check it. So what was wrong with, okay, suppose I don't remember what is wrong, which one, m1 was having impact or m2 was having impact, I don't know, but the graph should show. So let us see it. So let me put it m1 and control enter. See, both the slopes are almost same. So that means this is m1 M1 is insignificant. I don't remember M1 was significant or M2. Still the graph is showing. Now let me see. M1 will be having insignificant effect. Again we will see from here. Indirect effect M1. See, more than 0.05. It is insignificant. Even the graph is showing. So these are both slopes. After M1 has mediated and when it is not mediated. These two slopes are different. But they are almost same. That's why it's insignificant. Now let me show you about M2. It should be significant. The gap should be there between the two slopes. M2. Control Enter. See, the gap is very, the slopes are different. That means M2 has a mediating effect. After M2 is mediating, the slope changes. This is what the graph is showing. But in M1, the slope is almost same. So I hope you understood how to see this consequential or serial or sequential mediation and how to analyze this. And I will try to make one more video in which M1 and M2 will be having impact. But then we will calculate which impact M1 is having higher impact or M2 is having higher impact in mediation in the next video. I will try to get that data from somewhere and I will try to experiment with that, and then I will make a video. In that we will try to find the difference between the two effects and which one M1 and M2 both are having effect, but which one is having more effect we have to find from the R programming. So that is the next video I am planning to make. And also if you are interested in my channel and you want to support my channel, please subscribe. I will be happy. And please comment if you want to add some other videos. I will try. Even I am planning to do panel and time series data analysis in R, and then also next some of the videos are about R regression analysis and their diagnostic tests assumptions. That also I'm planning to make a video. I hope you enjoyed this one, and it is simple. Please don't fear this, because if you are doing PhD or if you want to be in academics line and if you want to be in the research field, then it's better to take a package which is flexible and which can do any analysis we want. So that is what R can do for you, and even all the support is there. Easily you can learn. Once you learn it once, see, so easy it is. Nothing is there in this. So I wish you all the best and stay safe, stay healthy. Good luck.